In the last few years, we've discovered quite a lot of exciting and really interesting exoplanets out there, with certain star systems even possessing exoplanets that could potentially be habitable and maybe even have some sort of an extraterrestrial life on the surface. But as our techniques improve and as new instruments are being developed to see even more, we keep discovering even more exciting worlds out there. Hello wonderful person, today we're going to be talking about yet another star system out there that has recently been discovered to have 5 exciting exoplanets, with one potentially habitable and one that seems to be approximately 1/2 of the mass of Venus, yet at the same time being the smallest planet discovered using a really exciting method. So let's talk a little bit more about this unusual star system known as L89-59 and find out what sort of planets we think they are as well. First of all, this is actually not the original discovery. The first time 3 of the planets were discovered was back in 2019. And back then, by using the TESS telescope, the original discoverers identified 3 potential candidates for what seemed to be exoplanets. It wasn't really confirmed right away, and the scientists were not certain what sort of planets they were, but the initial suggestions all suggested that they were actually terrestrial, relatively similar in size and in mass to planet Earth. But now, 2 years later, following more thorough analysis and investigations using a slightly different instrument, the scientists were able to establish relatively accurate measurements of mass, density, and also discovered 2 more exoplanets hiding somewhere in the star system, with one potentially habitable and being located right in the middle of the habitable zone as well. And now let's start right here. This is the image created by the European Southern Observatory. This is the solar system with Mercury, Venus, and Earth. And that's the star system we're talking about, L98-59. In this case, you're not actually looking at distances, but instead this diagram is scaled in order to make the habitable zones of the solar system and the other star system to match in the same region, with the rest of the picture showing us a kind of a temperature scale or a temperature gradient away from the star all the way to the end of the habitable zone. And since this is Mercury, it means that in L98-59 there are 2 planets that are even hotter than Mercury. But I think the most exciting part about this study is actually how they found these new planets and also what they used to analyze the original discovery as well. First of all, this is at a distance of about 35 light years away from planet Earth, so not too close, but also not really far away either. In order to perform a new analysis, the scientists from the European Southern Observatory use the most powerful spectroscopic instrument known as ESPRESSO that collects the light from the ESO's telescopes and then analyzes the changes in the frequency of light in order to see if the star itself is being pulled at by anything else. Okay, so it's actually easier to understand this if I show you a visual example here. So this right here is our sun, a copy of our sun. Right now it doesn't actually look like it's doing anything, and it doesn't look like there are any planets in its orbit. But once I zoom out, you'll notice there's a planet Earth, and it's orbiting in the same area where actual planet Earth orbits as well. But how can we possibly find it if there are no other signs for this planet, if there are no actual indications, no shadows showing, and no other way for us to see anything? Or in more scientific terms, it doesn't show us any transits, there are no shadows. Well, here we have a different method, and this is called radial velocity. This method works with a very simple principle. Because the planet and the star both contain mass, they actually end up sort of dancing around one another. Obviously, the planet being less massive moves a lot more, but the star is also sort of wobbling around a central point. Now for the solar system, our Jupiter does most of the pulling. It actually moves the sun by quite a lot. But even our tiny planet Earth has a bit of an influence on the sun. It shifts it just enough that if you were to have a powerful instrument, you would be able to find it. And that's precisely what ESPRESSO does. It looks for these tiny wobbles, and it finds those wobbles by looking at redshift and blueshift effects coming from the star. And so once again, if you look at the simulation from NASA here, notice how as the planet moves around the star, it either blue shifts or redshifts the light from the star. It's not a very dramatic effect, but if you have a powerful instrument, you can actually see this, and it's going to be periodic, and it's going to be detectable using modern methods. Here we're talking about changes in just a few hertz of frequency. Okay, so going back to our sun here. If I were to show you what's happening to the velocity of our sun by actually using the frequency change observations from the sun, it would sort of look like this. Every once in a while, specifically every 365 days, the velocity of the sun would change by about 18 centimeters per second. And that's because the Earth is pulling at the Sun and is making the Sun wobble just a little bit. And so that's kind of what the scientists in this paper did and analyzed the frequencies coming from this particular star system, eventually realizing that certain frequency changes seem to have a period coinciding with a potential planet orbiting in the region. And because 3 of these planets have already been detected using another method, they were able to confirm the existence of these 3 planets, but also discovered the mass of these planets, which allowed them to discover the density, and then discovered 2 more potential candidates. And so here the analysis suggested that the nearest planet seems to be about half the mass of Venus, approximately 0.4 masses of planet Earth. But because this planet is so close to the parent star, it's also probably kind of hot here. Nevertheless, this is definitely a rocky planet. The second object, which originally was thought to be some sort of a Neptune-like object, is also very likely a terrestrial world, a somewhat hot terrestrial world. And with a mass of about 1.4 masses of planet Earth, this is also a pretty exciting object that they were able to discover. The third object, which is a lot cooler in this case, is also pretty massive. It's about 1.5 masses of planet Earth, but for some reason it also seems to be a lot less dense. In this case, the scientists think that it's because it's an ocean world. It probably contains about 30% of mass as water. But because of its location in the star system, it's really unknown what sort of conditions this water is in. It could be just a really large steamy planet because it's actually pretty hot here, or maybe it's extremely hot and steamy on one side, but actually has a liquid ocean on the other side. So this could also be an extremely interesting object that they discovered. Here's the artistic representation of what this world might sort of look like. Although obviously it's not clear if it's actually blue like you see right here, or if it even has the water on the surface. But then they found 2 more planets, potential candidates, slightly farther away, but in the area that's more habitable. Neither one of these planets transits in front of the star, so it would actually be impossible to see their shadows or to study their atmospheres, but they do seem to be there based on the observations from Espresso. So this one here is roughly around 3 masses of planet Earth, and it orbits around the parent star every 12.8 days. Now this might sound like it's really fast, but because this is a red dwarf, things here happen a lot faster as well, and this is why the planets are so much closer too. The star itself is about 3 times lighter in terms of mass than our own Sun. It's about 0.32 masses of the Sun. But it's really this last detection that seems to be the most interesting. First of all, because it's pretty much in the middle of the habitable zone, with the average year being about 23 days in length. But also because it does seem to be terrestrial, with a mass of about 2.4 masses of planet Earth. And depending on the atmosphere and a lot of other conditions, this planet has a huge chance of having actual terrestrial conditions on the surface. But unfortunately, since it does not pass in front of a star, we're not going to be able to study its atmosphere until some of the other techniques come out, or some other advances in telescopes or new instruments. So for now we can only really estimate the mass of the planet. We're not going to know what else is going on here. Nevertheless, it's still pretty exciting to discover yet another multiplanetary star system in a relatively close neighborhood, about 35 light years away from planet Earth. And because there are 5 planets here, with all 5 maybe even terrestrial planets, this of course makes it one of the most exciting star systems discovered in the last few years. More importantly though, it allowed the scientists to really push Espresso to its limits. For the first time ever, they were able to confirm an actual relatively small in mass planet by using the radial velocity method. And in this case, the planet was only about half the mass of Venus. This is the smallest planet to have ever been discovered using this method, or I guess in this case rediscovered, or confirmed. Unlike the example that I showed you with our Sun and planet Earth, where the actual change in velocity is about 18 centimeters per second, planet B was actually changing the velocity of the star by approximately 46 centimeters per second, essentially making this the record as of today. But we know that Espresso can actually see even smaller planets, or even less massive planets. Its limit currently is about 10 centimeters per second, which means that at least hypothetically, if Espresso-like instrument was looking at planet Earth, it would definitely be able to detect it orbiting around the Sun. Which of course also means that we're going to be discovering more of these planets, with possibly even smaller objects out there in some of the future studies. But until then, that's all I wanted to mention. Check out all of the relevant links and papers in the description below, subscribe if you haven't, share this with someone who loves to learn about space and sciences, and maybe come back tomorrow to learn something else. Maybe support this channel on Patreon by joining the channel membership or by buying the Wonderful Person t-shirt you can find in the description. Stay wonderful, I'll see you tomorrow, and as always, bye bye.